Hi everyone, welcome back to our YouTube channel Becoming a ROS Developer. I'm Desire, and today we've got Matthew, who has just completed the course ROS Basics with Python, and he'll be giving us a presentation on that. So first of all, we'll see his code base running on the real robot, and then after that we'll get him to explain the details and how he implemented this project. We'll also be asking questions as we go along. So let me hand over the platform to him so he can begin his presentation. All right, Matthew, when you're ready.
Good morning. Thank you. This is that. Before we get into it, I think it's just my Wi-Fi being on the fritz, but I've had some connectivity issues. Things might go sideways on the robot in ways that I can't really control. But that's why God gave us simulations, because those don't actually rely on Wi-Fi. So first and foremost, the robot is going to call a server that's going to get it to an appropriate distance from the wall of approximately 0.3. From here, my wall following logic is going to take over. If you see here in terminal, it's printing like, oh, left is at this distance. I'm turning this way. Now it's taking a corner because it detected corner. You're getting odometry values spit out, left values, basically, oops, there we go. So here it looks like it's going to corner again pretty soon. I really hope it doesn't clip that corner. It's probably going to clip that corner. Rip. Yeah. No, I mean, that's just part of working with real robots, is they're just going to clip stuff occasionally.
Yeah.
But I mean, demonstrated therein is kind of the crux of my logic. It's like, okay, if I'm a certain distance away, then turn based on that. And if I'm already turning, wait a number of cycles of just going straight, so that I don't have the robot just like spinning in a circle. That was a problem I was having for a while. I'm actually very proud of my solution for that.
So you try to so your implementation of compound movements, right? So like rotating while it still has got some linear velocity was a way of countering that effect. Is that right?
Yeah.
Okay.
I mean, the instructions recommended, I don't know why it turned there. Okay. Once again, this is an example of bad LiDAR data, if I'm not mistaken, which is another part of just working with a real robot.
Did you try to run it before then to just see if it would complete the loop?
Before this, I ran it a couple times, and I was getting basically the same problem I am now. It's really stuttering, the feed is freezing randomly, and it's spitting out bad LiDAR data. That's why I opened with, hey, my connection's garbage, so the real robot's behavior might be somewhat finicky.
Okay. Let's see how it goes now. And
yeah, I mean, if nothing else, we saw the first half of that circle complete. And bad goes worse, I can get the rest of the logic and stuff worked out on simulated robot. Once again, you'll notice it's stuttering, it's jumping around. And, as long as my program and the robot are not talking, then things usually are not going to work, which is unfortunate. I'm assuming it's probably going to corner there. And then let's see, left value, post corner complete. Yeah, the problem is it stutters, and on my end, the command to stop the corner doesn't get published in time, meaning the robot turns for way more than it's supposed to. Also, random resolution drop. So, yeah, once again, I don't know if it's my connection or what.
Can you try have it start from a different spot?
Yeah, that's what I'm trying now.
Yep. But if your code is running on the hang on. All right, let's have it started from there, and then we can see.
Mm-hmm. I mean, once again, it is what it is. This is just part of life. This is part of being a robot code developer and doing this whole mess. Um, Actually, I just realized I probably should have moved that sign over there. Because the robot's either going to bump into that or, yep, this is another instance of data that did not get transferred fast enough and it ran into a wall.
So you had these experiences even when you were testing. It was still exactly the same, right?
So 2 days ago, when I
Mm-hmm.
was testing this, it worked pretty well. I was satisfied. That's when I made the reservation.
Mm-hmm.
This morning, when I logged on, is specifically when I was running into the connectivity issues
Okay.
of, okay, the robot isn't working, um, like it's freezing, I'm getting, like, the resolution is dropping all of a sudden, that sort of thing. Um, it even got to the point where the robot wasn't accurately responding to the joypad or joystick thingy, the thing you use to manually move it around. I don't know what the technical term is for that you guys use.
But I'm thinking, once your code is running, then you shouldn't have this. It shouldn't be crashing if the algorithms is being implemented correctly, isn't it? That's why I was asking. When you tested it and the connection was not bad, did it work at least? Did it manage to complete the loop?
Oh, yeah. I mean, I was very pleased with the results, and that's why I reached out about scheduling this appointment.
Mm-hmm.
Because it was consistent, it was fairly fast. I was pretty pleased with how it looked. So I'm like, cool, let's do this. Um, I mean, here's unacceptable run so far. It's not tremendously stuttery.
And
Uh,
okay, so when you are doing like the in retrospect, right? When you're thinking about what might be causing this, what is your first what's the first port of call? What do you think is probably causing this, based on how you
so,
implemented your wall following behavior?
um, one thing about my wall following behavior is it is kind of dependent on, um, there are a lot of conditions under which the robot moves forwards basically all of the time.
Mm.
So if there's any miscommunication between whatever machine is issuing the commands to the robot
Mm-hmm.
and the robot itself, that means it's probably going to crash into something because it's not receiving the new updated data telling it, okay, left is less than 0.3,
Mm.
turn right. Or, there's a corner at less than 0.5,
Yes.
take
Okay.
a corner.
All right. I think I'm beginning to see what's going on here. So, can you tell me how you implemented your laser scan callbacks? Right? Are they running? I mean, the laser scan callback, is it running in the same thread with the um,
So I
wall
have
following callback?
no, actually, I have a multi-threaded executor. I mean,
Mm.
now's as good of a time as any, I suppose, to break into the code if we're going to do this.
Yeah, sure.
Um,
Because I'm also thinking maybe you might have some concurrence issues there. So, like when one
yeah.
is trying to do something else, the other one is
So,
blocking its execution, right?
so I set up a multi-threaded executor,
Mm.
and then down here in my main, I have I add that, and I put it as part of a um, actually no, that's something else entirely. So the multi-threaded executor, as I understand it, means that different callbacks uh, don't have to wait on each other, basically, because there's an example given from the lessons in this book where LiDAR scans not updating because the robot was moving meant that the logic that was going to tell the robot when to stop never triggered, so the robot would
Yes.
just keep going infinitely, and it was this whole mess.
Yes, that's what I'm also
Um,
thinking. Yes.
so it being part or it being a multi-threaded executor
Mm.
prevented that from being an issue, um, in my experience. And
Mm.
to the best of my knowledge, that is what I can do to avoid that.
All right. So
Um,
when you use a multi-threaded executor, you do have to specify how many threads you intend to use, isn't it?
If I'm not mistaken, it's 2 or 3 by default.
So you were relying on that one then.
Yeah, and to be fair, I really only need the 2 because I have the movement callback and the LiDAR.
Yeah, I think making it explicit is also very good because it's self-documenting, right? No one has to assume when they see your code to say, okay, maybe it's running 3, maybe it's running 2, right? When you put the number there, everyone knows it's running 2 threads, right?
No, I mean, that makes sense.
Yeah,
I can just slap a to-do in here about that for posterity.
Yeah, it's just something that came to mind because I was thinking maybe your laser scan data is stuttering because there is this change of the context switch between the laser scan callback and the wall following control algorithm.
I was running into that specifically for a while also, but this by and large got that eliminated.
All right. I highly recommend you try to get a clear understanding of what's really going on, because if you're already using a multi-threaded executor, then you're not supposed to be having these issues unless there's something else that's going on that we cannot see in the current moment here.
That's what I'm trying to figure out.
All right.
To be fair, I don't know. I can ask you some more questions about that after the presentation's over. Bad goes worse.
All right.
Working through.
Yeah, let's go to the wall finder. Yes.
Working through my code in order of appearance. First, we have the wall finder. There's a little bit of extra code here that just haven't cleaned out. The wall finder is the thing that makes it turn, move to the wall, and then turn back. I have this hard-coded to 90 degrees because assuming the robot is facing parallel, assuming the front of the robot is parallel to the wall, 90 degrees will always be the shortest path from the robot to the wall.
Can you do something, Matthew? Can you just check if you stopped the script that was executing on the robot so that we don't have it running while we are talking about this?
Yeah, we're good. See,
okay. All right.
It's perfectly stationary.
All right. Good.
So in here's my init. Here I'm getting service server built up, that sort of thing. Laser scan callback. I have a function for waiting on the laser scan callback. I use a Boolean for that. That's been very necessary.
I think this one is actually. Let's talk about this in more detail, right? Because we want to understand what did you do with the laser scan data to find the wall, right? So I think this is very important for you to slow down a little bit so we get to understand.
Yeah. So once again, the base assumption I worked off of was that the robot was facing 90 degrees, so I don't need the laser scan data to find the closest point. That I can hard code as 90 degrees. What I do need the laser scan data for is, if I'm not mistaken, find wall callback, use it. Yeah. Is the moving towards the wall to an appropriate distance. For a while, I tried to do this of you read the distance, you subtract 0.3 from it, and then you move that distance. But I was really having some trouble getting that to work.
All right. So how did
you do it? Here we have... hold on. Here we have the rotating stuff. Not terrible. So then, this is... Here I'm getting... actually, I think I have a lot of weird bloated code I need to get rid of in this. I extract the distance from before, basically. Oh, and then this is the distance I need to move away from the wall. So I also have a little 0.02 tolerance, which is nice. While true, I wait on the laser scan data. I print out, this is how far I am. This is what my target is. I wait on the laser scan. If the front distance is less than the target distance plus tolerance, I break. If not, I stop. Wait for laser scan data to update. check the distance. So it's this block here, and this part specifically that publishes the forward movement. But if the distance is less than or equal to the target distance, then it just breaks when it gets there, which will break this while loop, which will just spit you out right back here, which I just have a distance checker put in place. This always throws successfully. It's fine, great. And then it goes to the rotating 90 degrees back.
So you're saying
Yeah.
when the threshold value gets to 0.3, that's when the robot stops and then rotates 90 degrees left or right?
Yes. So it rotates 90 degrees left first, moves forwards an appropriate amount of distance, and then
Um,
rotates 90 degrees back because
when
that has the left.
All right, when you say appropriate, give me a number, right? You had to choose a number. How does it choose how far to go?
It moves. So this is the target distance that it moves to, plus this tolerance. Once again, that's the logic of it gets the laser scan,
Yeah.
prints it, gets it again, and if the updated laser scan data for what it sees how far away the wall is less than the target distance, which is this number, plus the tolerance, which is this number, because real LiDAR is fuzzy, then it will break out of this while true loop. If not, then it publishes the MSG, which has a linear component connected to a linear speed that I define here, so it keeps moving forwards.
To get to within that threshold, the
Yeah.
0.3 plus 0.2 or negative 0.02.
It's once again, basically 0.3 plus or minus a bit, because I couldn't get it to. So when I didn't have the tolerance there,
Yes.
I was having some trouble to get this condition to actually proc properly.
Okay.
And sometimes it would just run into the wall for what felt like no reason.
Yeah.
I put the tolerance there for like, okay, it's probably going to read some LiDAR data incorrectly. The surface might be reflective, yada, yada, yada.
It's understandable, yes.
So there's that. So
Alright.
I check the distance, I rotate the 90 degrees back, and then all of this code, actually funny story, for a while I was trying to use calls to this service server as a means to get the robot to move to within 0.3 of the wall dynamically, like as it was making the loop around.
Yes.
I couldn't get this to work. It was no fun. It was setting itself on fire. So I just ended up moving all that logic back to wall following .py, and this is kind of a relic that I haven't cleaned out yet.
Yeah, so because I'm also thinking the reason why it runs into the wall, as we have seen, is probably because there is no corrective measure that has been implemented, right? So what I'm pointing towards is once you set a certain linear velocity, right? Because the robot knows that, okay, I am like 0.6 or 0.7 from the nearest wall, like the one that's in front of me. It's going to keep moving at whatever linear velocity we set, but it will stop keeping to keep checking whether the wall on its left or on its right is being followed in a parallel manner, right? So I'm so thinking if you had added that kind of system or that kind of constantly checking for laser scan data to see if the distance has grown smaller than 0.3 or smaller than 0.28, for example, plus or minus your tolerance, it will probably be able to go around well.
I have that, but that does not live in this file. That is a wall following .py type thing
Yes.
I can show. I do in fact have that, I promise.
Okay, let's see that. We've got a couple of minutes left, so
cool.
Let's see that.
So yeah. I did a whole bunch of really interesting stuff with the way that the robot just processes data weirdly, and the fact that commands and stuff are not always issued instantly on a real robot. That was a fun challenge. Anyways, getting into my movement, this is my command velocity callback. If not service server done, return. This is basically to keep it from moving while the service server is trying to move it.
Mm-hmm.
And then I add a 2-second delay afterwards, just because I was having some problems where when it was rotating back 90 degrees the second time, the robot would start moving prematurely, and I'm like, I'll just throw a buffer in there, and it works fine. And then if it's waiting for a LiDAR scan, i.e. it has not received new LiDAR data since the last time it moved, I publish twist, which just gets it to stop because it's all zeros, and then I return. In addition, waiting for server turn does the same. So I get the min distances from min distance associated with front and left. If they're not defined, then these values get set to infinity. I print the left value. If I am cornering, then I keep cornering. This is basically what's going on here. If elapsed is less than corner duration, it keeps turning. Else, then it finishes the turn. Cornering is false, post-cornering is true, post-corner start, yada, yada, yada. Post-corner, I did have it do some forward motion to try to stabilize. That just ended up making it run into things, so I eliminated the specifically linear part of that.
Mm-hmm. So can you explain more what you were trying to do exactly
this is kind of the same
in the post-corner behavior? Because I also want to know what were you trying to cancel out.
So for a while, it was hard coding some forward motion in there so that the code was run. It was kind of basically doing the same thing as it was with the service server of it's still trying to finish the corner, and then right at the end of the corner, the other logic takes over improperly. So what I ended up basically making this do is after the corner, it waits a couple seconds for LiDAR to update, waits a couple seconds for just kind of everything to stop moving for a second.
Okay.
So that's what's going on here.
Okay.
And then here we have my corner checking logic. If front is less than this threshold, which was provided to us in the instructions, and not double check, I was running into an issue where as long as that front detects a value less than 0.5 once, it was cornering, which was great if there was actually a corner there, but sometimes there wasn't. So what I did is I had it so that if it's true the first time, it sets a Boolean, yada, 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 return, and then it forces it to do a second time through, and it forces it to make a second check of that data after the LiDAR data has been updated again, which I'm actually really proud of. It's a fun little solution to LiDAR data potentially returning something incorrect.
Okay.
So, and then it just...
all right. So how long did you wait before you had that Boolean be checked again?
So it gets set here, and then this returns. So you have to go all the way down another execution of this function. And then, so this isn't going to hit, or this won't activate because double check is now set to true. And then you get here, and this will only go off if double check is set to true.
All right.
And then this is what sets up the Boolean of okay, I am cornering. My start time is now. My last corner time is now.
Okay. All right.
Then I get to other while following logic.
So
setting a linear velocity.
All right. Sorry to cut you short a little bit, but I want to know can you describe the exact behavior before you implemented that double check?
The robot would be in a position where there's a wall greater than 0.5 away. And then for some reason, the LiDAR would return, in front there is a value less than or equal to 0.5, and it would begin to corner at a time when it shouldn't, and it would run into something in the middle, or it would just start spinning in a circle. Not good.
I see. Okay, so how many values are you checking for if they're within the, let's say how many of the laser scan indexes are you checking if they are above or below 0.3? Right. Are you checking for all three in the front, or you're checking
0.3 or 0.5? Because front is 0.5.
All right, so that's your maximum. You're saying if it's 0.5, I can go forward a little bit.
What I'm saying is if the value is greater than 0.5, then keep going down to the rest of my movement logic. If the value is less than 0.5, it means I'm looking at a corner, so I need to turn.
Okay, only for the front index, right? Not for the front left or the front right?
Specifically front.
Okay.
Which actually, yeah.
Okay.
Yeah.
So where I'm going with this is, what if front is greater than 0.5, right? And front left is like 0.28, for example, or maybe 0.25.
So there is no front left. There is front and there is left.
Okay.
Front corresponds to directly straight out of the robot.
Yeah, yes.
Left corresponds to directly 90 degrees out the left-hand side of the robot.
All right. All right, I see. So for the wall following behavior that you're trying to implement, you only have to consider that one front right?
Not front right, just front.
Okay, all right. Where I'm going with this is, we probably have got some of that, I don't want to call it, if you don't check those parameters, right? If you don't constantly check the sides of the robot, so that means the laser scan indexes that are not exactly in the front, right? So those that are slightly to the side, right? They can help in correcting the wall following behavior. That's why I'm asking this question. Like, are you doing any form of handling for the laser scan indexes that are not exactly directly in front of the robot itself?
I didn't really see a need to, so I didn't.
Okay, all right.
That's something I'm interested in exploring.
Right. Yeah, it's I think it will probably also like help get more consistent behavior, I think, because then there are more, it's like more control parameters you can check well beforehand, well before it crashes. The robot can check its distance to the wall while there's still time for it to correct, right?
I mean, once again, I wasn't exactly having problems with it crashing into stuff on executions prior to this morning.
All right.
So,
all right.
That's what makes me somewhat like, why is it behaving the way that it is?
Yeah, something has changed. Yeah.
So, cornering logic, getting into my actual normal following logic. So what I have is I have two booleans, turning left and turning right. These keep track of whether or not the robot has started to turn left or started to turn right, because if I just say, if less than 0.3, publish an angular velocity of this, the robot is just going to spin in a circle.
Yeah.
It needs to turn slightly and then go forwards for a while.
Yes.
And then turn slightly more if it still needs to correct.
Right.
So that's the number of cycles is represented by left cycles and right cycles. See, I'll start down here because this is probably the easiest place to explain.
Yep.
So if left is greater than 0.31 and I'm not turning left,
I
print a console command. I set turning left to be true, turning right to be false, staying straight to be false. I publish an angular so that I turn left, and I set right cycles to be 0. And then the next time through, so turning left is now true. So I'd hit this and I'll say, okay, well, left is this, I'm cycling, which means I'm just going to await, basically. I'm not going to do anything. Except for if left is greater than this, I'm going to set left cycles to be free because that's the maximum number of cycles.
All right.
I'm just going to add one cycle so that if it's less than 0, or if it's greater than 0.3 for all 3 cycles, it'll just add one at a time. But if it ever gets to less, then it'll immediately have a condition so that this block gets activated, which is, okay, I'm turning left, but I'm not turning left hard enough. Basically, I need to set turning left to be false again, so the robot tries turning a little harder left.
All right, Matthew. I think
So that's what's
we
going on with the resetting.
we're out of time, but thank you very much for your wonderful presentation and also giving a detail on the difficulties. Yeah, so just hang on for a little, okay?
Of course.
Alright everyone, this was Matthew's presentation, and would like to thank him for really giving us details about what went right and what didn't go so well, and would like to encourage all those of you who would like to take on this course or any other courses we offer certification on to do so, and you can come and showcase your work. So until next time, keep pushing your ROS learning. Bye bye.